Good afternoon. How are we doing? I hear you without my thing. How are we doing today? Good. What can I help you with today? What have you been working on? What have you been playing with that you'd like to look at? Like nothing. We like nothing. Open that chat in case you guys throw things in there. So let's see. You guys don't want to look at any?
I don't really have anything I need to like look at or understand more. It's more of just like getting the time to do the assignment for today.
Yeah, it's actually often kind of surprising the change in how much time this class takes up than like say 95 or whatnot. It's sometimes deceiving because we are talking about a lot of the same material, but because we're doing it a little differently, a little bit deeper sometimes, it often takes a bit more time and a lot more kind of out of you. And some of you guys have been talking about that. I'm in the comments that, or in the forums, that you're already starting to see that and realize that you've got to orient towards this class maybe a little differently than you did something like 95 or 65. And that's a good thing to realize early, that you do have to put aside more time and put aside more kind of other things to make this work. The biggest thing, the function of the section on lines. Lines, ideally, they're in your background, so you're just, it is one of those things that you're knocking rust off of. But the big kind of skill in lines is being able to build lines from points. So if we look at build a line from 2 points. And unfortunately, this skill of building a line from a couple of points is often taught or often reinforced in kind of a disadvantageous way, not the way that's best to kind of go on from. So I want to look at a fairly simple couple of points, build a fairly simple line, and kind of do it in a way that might seem a little foreign at first. And then talk about like how that makes for a good technique for building lines, connect it with some things you have hopefully seen, and try to strengthen some of those tools. So to do that, we need a couple of points. So let's say I just want some fairly nice points. How about the 0.25 and 0.25 and 6, yeah, 6, 7. So 2.5, about there, 6, 7, about there-ish. So we should have a relatively flat, positive slope, and nice equation for a line. Should have some nice y-intercept. So to build a line from any information, to build a line, we need 2 things. We need 2 pieces to build a line. We need a slope, and we need a point. That point doesn't have to be the y-intercept, doesn't have to be the x-intercept, doesn't have to be any particular point. We just need to have a slope and a point. If we have those 2 things, we can make a line. Now, luckily, we've been given 2 points here. So either one of those will satisfy us needing a point, but we do need to find a slope. Talked about slope a fair amount last time. You guys know how to find slope. So if we take this and we want to find our slope, we often use m for slope. Anybody know why we use m for slope? M seemed kind of random. It's the first letter of the French word moher. I don't speak French, but that means to ascend or climb. So it's the amount of ascension the line has. So it's just from the French. That's why we use M. In case you were super curious. So it's the change in Y, the change in the output variable in ratio to the change in X, change in the input. I really recommend whenever you kind of have to use that formula for slope, you take just a second and label your points real quick. It takes a couple of seconds and it saves you from making the kind of irritating swap mistakes that give you some problems with your positives and negatives. It certainly isn't necessary, but it's one of those things that takes 2 or 3 seconds and you won't make that annoying error. So it is a recommendation. And it doesn't matter which one's x1, y1, which one's x2, y2, doesn't matter at all as long as it's consistent. So label them however you want and you won't flip them all the way through. So that would be what, 7 minus 5 over 6 minus 2. So that's going to be, what, 2/4? Oh. Well, I wanted a nice straightforward slope, so nice slope, positive 1/2. That's our fairly flat but positive slope. So slope of 1/2. So now we have a slope. We need to have a point. It doesn't matter which point we use. I'm going to grab the first one because it's the first one. And from those two pieces of information, we can make a line. Now I'm going to jump off to the side here and talk for just a second about our equations of lines. Equations of lines, equations for anything, equations that make graphs, are rules for XY pairs that make our statement true. So like if we have a line, let's say y equals 5x plus 4, it's not this line, just some random line, our solutions to this equation are x and y pairs that make the statement true, right? That's what it means to be an equation. So all the points that are on the line are xy coordinates that make this statement equal. So like the point 1, 9, when x is equal to 1, y is equal to 9, that point makes the statement true, so it's a point on that line. That's what we're trying to build. So for this line, we just calculated the slope. We found that the slope is going to be 1/2, which means, because lines have a constant slope, that means that slope of up 1/2 is going to be true for any pair of points on this line, right? You grab any 2 points anywhere on this line and find their slope, that slope has to be up 1/2 in ratio. Fair? So we know a point. One of the points we know is the point 2, 5. So if we took any y value minus 5 over any x value minus 2, this 7, 6 was, this 6, 7 was a particular point, but any xy pair that makes the slope also 1/2 is a point on the line. Does that seem reasonable? Every XY pair that will make that slope of 1/2 with our 0.25 is an XY pair on our line. So in a very technical way, this equation right there is an equation for our line. Every XY pair that makes that true is a point on our line. That's an equation for our line. It's not in a form we like. It's not what we'd want to look at, not what somebody would expect to be told if they were asked for an equation for a line. But it is, again, in a very technical sense, that is an equation for our line. Now, if we wanted to make it more useful or more like we kind of like to see, we might try to manipulate it. Might multiply both sides by x minus 2, multiply this side by x minus 2. That would make those x minus 2's cancel, leaving the y minus 5 on that side, and the 1/2 times x minus 2 on the other. I just switched the order on you. And again, that's an equation for our line in a little bit nicer of a form. If we wanted to make it even a little bit nicer than that, we might add the 5 to both sides. So y equals 1/2 x minus 2 plus 5. Again, still an equation for our line. A little bit nicer. Distribute that 1/2. 1/2 x minus 1 plus 5. Hard to avoid doing that addition there. Y equals 1/2 x plus 4. Each one of these is an equation for our line. This one is even in a form we like, right? All of this is really just a manipulation of that slope formula. That line, this line, comes from making that slope constant. Fair? Now, I'm not suggesting that every time you make a line, you start from here, but it's frankly really convenient to start building your lines from about this stage. If we generalize this, this says y minus, that 5 was our y1. Y minus y1 equals that 1/2, that's our slope. Then we have x minus, that 2 is our x value. So that's our x1. How many of you have seen this form of a line before? A couple of you. It's often referred to as the point slope form of a line because it has a point, x1, y1, and the slope, m. So point slope form. And really, you can hopefully see that it really is just a manipulation of this slope formula. You multiply that denominator over and you get point slope form of a line. But then to build our line, all we've got to do, plug in the xy values and the slope we know. So y minus the 5 equals 1/2 x minus the 2. And we have an equation for our line. And again, if all we needed was an equation for our line, we'd be done. We might like to clean it up, and we will often be asked to give lines in slope-intercept form just because that's kind of the standard form that's nice. But from the perspective of building a line, starting with this point slope form is really helpful. For example, if you have a slope of, I don't know, say 3/5, and one of your points is equal to, I don't know, I don't want to use fractions yet, do I? Don't worry, we'll do one with a bunch of fractions in it. It'll be fun. Let's say one of the points is 4, -3. If you want to build a line with that point and that slope, starting with your point slope form is really handy. A lot of folks even go one further. They'll do the addition and use mx minus x1 plus y1. So I don't know why my y's keep changing. So this is just a slightly modified point slope form that's nice to start with, but you can start at either place. So we'd have y minus the -3 equals 3/5 x minus the 4. And that's the equation of our line, which we should clean up, but still, that's the equation of our line. Take 30 seconds or so and clean that up down to a nice slope-intercept form. You guys end up with 3/5 x minus 27/5. Got at least one yes. That's good. Questions about that? How many of you were taught to make lines this way? Oftentimes, some people have seen it before, but people tend to gravitate to the kind of alternative method, and that other method, it's got problems. It tends to be slower. More little errors tend to happen when people do it. This pattern of finding the equation for lines, once you get real comfortable with it, it tends to be faster, more accurate, less errors. Flowers bloom at your feet as you walk. And the biggest complaint I tend to hear about this particular method is the idea of having to remember yet another formula. And I sympathize with that. I don't like, remembering formulas. But my response to that tends to be that you know this formula because you know this formula. Multiply that over and you have point slope. It's not a new formula. It's a slight modification of one you all walk around with. Fair? So let's make this, I'm going to say bad. Let's make it fun. So given a couple of points, it's always good to practice our fractions, right? Let's say 3/5 and -2/3, 1 point. And the other point is going to be, should I keep, let's have one of them be common and the other one not. -1/5 and 1/4. Build the equation of the line passing through those points. I'll give you a little while to do that, and then we'll go through it together, and I'll talk about some good techniques and habits for managing all the fractions and trying to make it a little bit, less horrible. This is Math 111, so I get to assume all your skills are just rock solid with fractions, right? You all love fractions, and you can just bust them out, no problem. Okay, I assume you understand how to work with fractions. Practice is good. If anybody turns those into decimals and tries to do it in decimals, I'm going to drop you. Okay, I won't, but I'll be torturous to you. Who labeled them, by the way? Anybody label them? No. I just suggested that minutes ago. Complex fractions. Yes, I wouldn't object. Turning that into -4/5. So I got a question for you guys. Who prefers fractions over decimals? Who prefers decimals over fractions? Two of you, the other four have no opinion. Got to have an opinion. So, okay, let's take the decimal people though. So people who like decimals better or who are unsure, if you like decimals better, take 0.125 and multiply by 0.25. What do you get? Okay, while they're doing that, fraction people take 1/8 and multiply by 1/4. What do you get? Which one of those is easier to do?
The fractions.
And by a lot. You guys have an answer for the other one yet? Probably asked a calculator. And these are the fraction versions of those decimals, if you didn't recognize them. Fractions are much faster and easier to use than decimals, and by quite a bit. The problem is fractions are harder to learn how to use than decimals. Decimals use the skills you already have, you just have to move the decimal around, while fractions require some new skills and new techniques, and they take a little bit to learn. I often compare it to driving a car. Ask, is it easier to drive a car from here to New York, or is it easier to fly in a plane from here to New York? Obviously, it's arguably, but it's easier to fly from here to New York. It's faster, it's more efficient, it's even cheaper technically. But which is harder to do? Learn how to drive the car or learn how to fly the plane? It's a lot harder to learn how to fly the plane. And fractions are the same way. They're harder to learn. They take more sophistication. They take more skill. They take more practice. But once you learn to be good with them, you can fly. I know that's the corny part of my story. But you really want to push those fraction skills because they will make your work and your everything you do with math much, much, much nicer, much, much, much easier once you get super comfortable with them. I often tell people, if you don't like working with fractions, like you've gotten okay with them, you're not bad with them, you just really don't like them. Okay, if you don't like fractions, get super good with fractions. Because the better you are with fractions, the better you will be at getting them out of your way super fast. For example, this problem is technically referred to as a complex fraction because it has fractions inside other fractions. I hate fractions in my fractions. The only thing worse than having fractions in your fractions is having decimals in your fractions. So I don't want to start working with those fractions. I don't want to get common denominators. I don't want to do any of that. That's a pain. I just want to get those fractions out of my way so I can work with the rest of this problem. That seem reasonable as a goal? What could we multiply by 1/4 to make that fraction go away? we multiplied 1/4 by 4, it would go away, right? What would we have to multiply by 2/3 to make it not be a fraction anymore? And he's giving me a 3 down there. Yeah, you have to multiply that by 3. That fraction would go away, right? What would we have to multiply by the 4/5 to make that fraction go away? If you got the pattern here, you're say a 5. Okay, so to get these fractions to go away, if we multiply by, well, 12 times 5, that's 60. If we multiply the top and bottom of that fraction by 60, 60 is kind of a big number, but that 60 is going to destroy all of those fractions. They'll be gone. You've seen this technique before, ideally. It's called clearing fractions. So we multiply that 60 by 1/4. 4 goes into 60, what, 15 times? So turns into a 15 times 1 is 15 plus 63 goes into 60. That's going to cancel 20 times. 2 times 20 is 40. 5 goes into 60, what, 12 times? 12 times 4 is 48. Our slope is 55/48. Now, clearing that complex fraction in that way takes a fair amount of, one, confidence with your fractions and really good fraction technique, but it makes really short work of that problem, right? Does that make sense? And this is what I mean. If you don't like fractions, if you're super good with fractions, you just get them out of your way. You don't like them? Fine, master them. If you do like them, great, master them, because then you can have all kinds of fun with them. So either way, being really good and solid with your fractions makes everything that we're going to do easier. And the more you try to avoid them, the tougher things are going to be. Cool? Every once in a while, I'll still get some people in math, in Math 111 who try to fight the fractions and try to use other things. They use the calculator overly much, and they fight the learning the fraction skills real well. And, you know, I try to talk them out of it. If I can, great. If I can't, that's fine. Because if they go on to Math 112, you do not leave Math 112 with bad fraction skills. It's not possible. It just plain isn't. You either get crushed or you learn your fraction skills. So any of you who are planning to take Math 112, start now, embrace them, get good with them. It'll make all of Math 112 easier, as well as every other thing you do with numbers. That's my little motivational speech for today. So that's our slope, 55/48. And sometimes I'll do things really fast with fractions. I'll kind of throw them around real quick. And if you're like, wait, could you slow down and go through the steps of what you did there? Because I didn't catch that. Stop me, tell me, slow me down and say, hey, could we, go through that more step by step? And, I hate to say this, but the last thing I'd want to deal with would be 0.03125. That's a horrible number to carry around. Carrying around 1/32, you just move that thing around, no problem. Carrying around 0.03125, ugh. 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 All right, so that's our slope. The other thing we need to make a line is a point. So it doesn't matter which one we use. I'm going to use the 3/5 and the -2/3. For no particular reason. And then if I want to build the equation of our line, I'm just going to grab that y minus y1, mx minus x1, plug those in, and we have the equation of a line. So y minus, I'll turn into a plus 2/3 equals 55/48 times x minus 3/5. Again, great. That's the equation of our line. If we didn't need it in a particular form, we could just leave it there. But we are, good, polite math students, so we're going to clean that up. I'm going to do the distribution and the subtraction at the same time here, just for convenience. So 55/48 x minus, that 5 is going to cancel with the 5 in the 55, leaving 11 over. That 3 is going to cancel with the 3 in the 48, leaving 16. So turn into a nice 11/16. That was convenient. And then minus 2/3. Okay, we're going to need some common denominators there. Common denominators never goes away, unfortunately. And those common denominators are going to bring us back up to 48, so might have been good just not to reduce over there with the 48s, but that's okay. So we're going to multiply those by 3, 33/48 minus, multiply by 16. Was that 32/48? So y equals 55/48 x minus, what is that, 65/48? And boom, that's the equation of our line. In a nice slope-intercept form. So this was obviously a bit of an icky one with the nasty fractions as our points. But the nice thing about taking 2 points and building a line is the mechanics don't change. No matter what those points are, no matter how good or bad or ugly those numbers might be, like, we change this to -pi over the square root of 5, that's going to make this problem really annoying. It's not going to change any of our mechanics. It's just going to make, some of the calculations a little bit more irritating, but it does, not going to have any effect on what we actually do. It'll look horrible. Questions about that technique? Now, I hate to mention it, I really do, but a lot of you were probably, if you can be said to have been raised on a particular math technique, have spent a fair amount of time with the idea of, okay, I'm just going to put this directly into slope-intercept form. We know we want that y equals mx plus b form. So often people are shown the technique and reinforce the technique. We just, put those in there and then take our x and y points, put them in for x and y, and you can solve for that b. That technique works. It's not wrong. In practice, I find that it is slower and tends to create more errors as opposed to less. But I do want to kind of look at it. So we plug in the X and the Y because, again, we know that that XY point is supposed to make the statement true. So we find the value for B that makes it true. Okay, so we're still multiplying these together. So our 5 still cancels. You know, that's the same calculation we had to do up there, just in a different spot. So that's still 11/16 plus B equals -2/3. Okay, we're going to solve for that B. We still have to subtract the 11/16, so we still have -2/3 minus 11/16 equal to, well, what's going to be the B? Let me write that nicer. -11/16 minus the 2/3 equals our B. We still need common denominators there, so the 11/16 we're still going to have to multiply by 3. 2/3 still going to have to multiply by 12. And hopefully you're noticing it's the same calculations, right? It's the same sum that we did here. It's the same product that we did there. It's really just a different organizational scheme. Minus, only multiplying by 12. Sorry, multiply by 16. 32/48. So B is equal to what? Negative, that's the same 65/48. So it's the same calculations. Why do I not like this method? Well, again, having built so many lines, when you're comfortable with it, when you're good with both of them, this technique does tend to be quicker and nicer. When you have to build lines just over and over and over and over and over again. But the big thing that I really prefer about this other method is as soon as we start, as soon as we plug in the values, that is a legitimate equation for our line. Everything else is just manipulating it into a form that we might prefer. But we start all the way, this is the equation of our line, so is that, so is that, so is this one. Fair? Where with this other method, this isn't an equation for our line because it doesn't have the B, so that's not an equation for our line. This isn't an equation for our line, that's a particular couple of values. That's not an equation for our line. That's not an equation for our line. That is not an equation for our line. That is not an equation for our line. And that is not an equation for our line. We don't have an equation for our line yet, and we've gone through 1, 2, 3, 4, 5, 6, 7 lines. Fair? And a lot of people will say, that's the answer. That's not the answer. That's the value you got for B, but that's not the answer. You were supposed to build a line. That's not a line. And other people will even go, I always hate to see this, and they'll write, okay, then the line is 2/3, -2/3 equals 55/48 times 3/5 minus 65/48. So they'll say, that's the line. That's not the equation of your line. That's just a true statement that -2/3 is going to equal all this. You simplify all that, you'll get -2/3 equals -2/3. That's not your line. You've got to take out the 2/3 and the 3/5 and put y equals 55/48 x minus 65/48. So I just tend to see more kind of errors in writing the answer down, in knowing what your solution is versus what just constants are that you found. I don't think it's any simpler. You're still doing the same exact calculations, and you don't actually get an equation until the very, very, very end. So I just don't prefer that technique. I don't think there's a lot of benefit to it, but it works. And if you really like it and you want to use it, go for it. I'm not going to penalize you for what technique you use. But for those of you going into calculus, I don't have any student who ever gets through calculus who's not using this method by the time we're done, because we build so many lines in that class, and you see this technique, how fast it is after a while. You're just kind of like, I'm using that one, you know? So you'll gravitate towards it eventually if you end up doing a lot of line building. But I'm going to encourage you to, try to start building some of those good habits and good quick skills ahead of time. But if you're, into doing it this way, that's what you prefer, particularly on things like tests, you're more comfortable with this, go for it. I'm not going to get upset by which technique you use. But do start, try this a little bit and see how you feel about it. Okay? Questions about it? Any of that? Most of the rest of chapter 2 is a couple of word problems. I do have some videos waiting for you guys on some of those word problems. I'm kind of waiting for you guys to start asking about them, so I don't send the videos out and have you guys go, oh, I haven't done that problem yet, but here are the answers. So now I'm done, because that's not going to help you at all, right? So like those problem with the truck problem on that tends to be really fun. So there's a couple of word problems in there. Fight with those. If you need some help with those later today, let me know. Let me see. I can check and see how you guys are doing on that homework assignment. Should I do that, or is that going to make me grouchy if I look and see how that homework assignment's going so far? It's the handed stuff. Oh yeah, overall it seems to be going fairly well. 1, 2, about 3 of you finished it. A couple of you are just starting it. You've waited a long time to start it, but you got some time, so it's okay. Some of you started to play with chapter 3. That's good. I'll start sending out chapter 3 stuff tomorrow. One of the big skills in chapter 3 that you guys are that most people fight with a little bit is completing the square. A lot of you will have seen completing the square in your background, but a lot of people kind of pass over completing the square. It's a really powerful and really useful technique. And we're going to focus on it a bit in our sections on chapter 3. So I'll send some stuff out about it, but you guys should have seen those techniques. Just, again, these first 3 chapters are a lot about banging off rust. Are you finding that's working, that you guys are, struggling with stuff enough to get some of that rust off, so you're working faster and better as you go along? Anybody finding trouble with that distinction between, oh yeah, I've seen that, and I have no idea what that's talking about at all? We talked about that, being careful about that distinction, and letting me know if you're starting to get into a lot of you've never seen something before. Like you guys have made lines before. Okay. Anything I can do for you before you guys wander off today? Okay. Again, I'm going to remind you guys, if you get stuck on stuff or want extra material on particular things, let me know. I want you guys to be driving a lot of that supplemental material based on what you guys need. For that to be effective, you guys have to, though, be working in time and working, not waiting until the very end to get things done. So I do want you to be, diving into that chapter 3 stuff, working ahead of our dates so that you guys can ask stuff and you guys can guide the extra resources that you need. Okay? Okay. If anything comes up, let me know. And I'll see you guys next time.
Thank you.
You're all very welcome.
Bye.
Bye.
Bye.